Hello and welcome. It is time for another exciting episode of Physics 113. In today's episode, we are going to begin discussing cosmology. Now, in my opinion, to really understand cosmology, we need to have a good understanding of the concept of space-time. So, what is space-time? A very recurring theme in this section is going to be that we think about what we learned in astronomy so far. We learned about planets and stars and galaxies, and those objects could be doing things. They could be colliding or orbiting or exploding, and that's wonderful. That's fun. But when we are saying that these objects exist and they're doing things, we could also meaningfully ask the question, where is all this taking place? And kind of in a way, we could say, what is the stage on which everything takes place? What is the location where everything occurs? The location where everything occurs is space. And if you really want to have a good understanding of what is cosmology, what is the modern model of cosmology, what is the universe, the Big Bang, black holes, we should have a good, robust understanding of what is space-time. So we need to really understand this stage on which everything occurs. Now, this picture in front of you, this is a real picture. This is not an error in the photograph. These blue streaks of this object here, the streaks here, these are actually real things in the universe. So, to understand space-time, to introduce it, I'm going to begin with this quote. This quote was taken from my advisor in graduate school's website, and I always thought it was a really neat idea that think about when we began taking 112 or 113, and I posed the idea that we exist in nature, and there is no manual to how nature works. So we have intuition for some regimes in nature. I know what 20 degrees is, I know what 50 degrees is, I know what 100 degrees is, but I have no concept for what is negative 500 degrees, or actually that doesn't exist, but I have no concept for what is negative 200 Celsius, or I have no intuition for what is the temperature like on the surface of the sun or in the middle of the sun. What is the pressure like there? Now, so we build mathematical models to try to describe how things behave there. We could conduct experiments that could recreate some of these conditions, not all of them, but some of them. And so we could learn more about how the universe behaves. Now, in a way, if we think about it, when the Earth was very young, there were some animals evolving, and then within nature, you had natural selection, various cycles of extinction, then species proliferated. And at some point, you had species come into that were able to look out at nature and really begin pondering what is nature like. So in a way, this is kind of like from non-living entities, you had life come to be, and this is going to be a major theme of the next module in 114. And then that creature that came out of nature looks back at nature. So this is kind of like nature meeting itself and observing itself again. Now, when we talk about the topics in this module, in this particular section, I was very careful with the words I chose in my slides. So take my words at face value. I don't want you to read into anything more than what I'm saying. So don't assume anything, because we all know what happens when you assume. And basically, like always, feel free to email me with any questions. Some of the topics we're going to be talking about in this module are more abstract than compared to some of the other sections we're talking about. So by all means, send me a question, any questions you might have. I will be responding to questions somewhat regularly as I receive them, and I will soon be posting a new homework. I am in the process of writing it right now. So, you guys may have seen something like this before. In high school, you probably saw the Pythagorean theorem. So what is it? Well, okay, we could write it out as an equation, but what does this equation mean? The Pythagorean theorem is a relationship between the sides of a triangle. So there is a mathematical relationship. The right side is the same as the left side of the equal sign. And there is a relationship between the two legs of a right triangle, which are labeled A and B, and the length of the diagonal. So presumably I could take a ruler, I could measure the length of side A, I could measure the length of side B, I could put those in an equation, get a number out, and there will be a direct relationship between the lengths of these sides and the length of the hypotenuse, the diagonal part of the triangle. Now, in the upcoming slides, I'm going to have a number of mathematical relations written in them. In this course, you're not going to actually need to ever perform a calculation, but there are a lot of recurring themes in the slides that, in my opinion, are very well demonstrated by having math. So I will not make you perform any calculation, but I want to show you how some equations change under different assumptions or under different scenarios. So another concept we're going to come across a lot is the idea of dimensionality. So dimensions come up a lot in some fun sci-fi genres. So what is dimensionality? For the context of this lecture, we could think of dimensions as the minimum amount of information necessary to describe your location. So what do I mean by that? One very simple example of dimensions is the number line. This is the exact same number line that you have seen since the first grade or since kindergarten. So think back to first grade, your teacher may have had a number line across the chalkboard. And think about what is a number line? It's just an ordering of numbers where you go 0, 1, 2, 3, 4, on and on. And presumably when you learn about negative numbers, you could go in the other direction, -1, -2, -3, and so on. Now, if you are standing on a number line, and if you tell me what number you are standing on, I know exactly where on the number line you are. So I only need one piece of information to completely specify your location on the number line. So I would say a number line is a 1D object. If you give me your number, I know exactly where you are. And this is assuming we both know where 0 is, how the numbers are marked, etc. Now, if you are instead standing on a 2D sheet, you need to give me two pieces of information. So you need to tell me where you are in the left-right direction, and you need to tell me where you are in the up-down direction. So I could almost think of a 2D sheet as just two number lines. So one number line I choose to call X, that will tell me where you are in terms of left-right, and the other number line I call Y, that will tell me where you are in terms of near the top of the sheet or near the bottom of the sheet. And if you give me those two pieces of information, how far you are in the left-right direction, where you are in the up-down direction on that sheet, then I could know exactly where you are. So a 2D sheet, you only need to give me two pieces of information to tell me where you are. So I kind of think of a sheet as a two-dimensional object. And we could extend this concept to a higher dimension. If you tell me where you are in the left, right, up, down, and forward, backward direction, that's basically like three number lines. And if you give me the information from your location on those three number lines, then I would know exactly where you are. So I would say, okay, if you are here, you are roughly about here on the X number line, you're about here on the Y number line, and you're about here on the Z number line. So with that in mind, we could ask the question, is a sphere a 2D object or is a sphere a 3D object? Well, if you're a geometrist, which is a branch of mathematics, you might say a sphere is a 3D object. The equation for a sphere is all the points that are equal distant from the center. So all the points equal distance. Okay, well, a sphere, you could have an X, a Y, and a Z, and it follows some equation like this. So a geometrist would say a sphere is inherently a 3D object. If you're a topologist, which is a different branch of mathematics, dealing with shapes and how shapes could be molded and stretched into other shapes, you would say a sphere is a 2D object. Because to fully describe your location on a sphere, you don't really need three numbers. You don't need left, right, up, down, front, back. You could fully describe your location on a sphere with just giving the latitude and longitude, kind of like where are you on the surface of the Earth. So one way we could reconcile these two viewpoints is by stating that a sphere, and I'm only talking the sphere, I'm not allowed to be inside or outside. I have to be on the surface of a sphere. A sphere is inherently a two-dimensional object that lives in, or we would say is embedded in, a 3D volume. So I'm going to stop here, and when I come back, I'm going to be talking about the notion of separation between locations.